Humankind has always gazed at the stars. We've pondered our place in this vast universe. We've wondered about the past and dreamt about the future. One question echoes through time. Can we travel through it? The idea of time travel, once confined to fiction, now stirs in the hearts of scientists. It's a tantalizing concept, pushing the boundaries of our understanding. Time travel isn't just about changing the past or seeing the future. It's about unraveling the fabric of the cosmos. It's about understanding the fundamental laws that govern our existence. The pursuit of time travel is a journey into the very essence of the universe. We often think of time as a river, flowing steadily from past to present to future. But what if this river could bend, loop, or even flow backward? Physics tells us that time is not absolute. It's relative, a dimension intertwined with space. This concept, known as space-time, is key to understanding the possibilities of time travel. Imagine a vast, flexible sheet. This sheet represents space-time. Objects with mass, like stars and planets, create curves and dips in this sheet. These curves are what we experience as gravity. The deeper the curve, the slower time flows. This warping of space-time, as predicted by Einstein's theories, opens up intriguing possibilities for manipulating time itself. Albert Einstein, a name synonymous with genius, revolutionized our understanding of time. His theory of special relativity, published in 1905, showed that time is not constant. It's affected by speed. The faster you travel through space, the slower time passes for you relative to someone standing still. Einstein's theory of general relativity, published in 1915, introduced the concept of gravity as a curvature of space-time. Massive objects warp the fabric of space-time, causing time to dilate or stretch. This time dilation effect has been experimentally verified, proving that time is not as straightforward as we once believed. Section 4. Wormholes, shortcuts. Through the cosmos. If space-time can be bent and warped, could we fold it entirely? Imagine folding a piece of paper so two distant points touch. This, in essence, is the concept of a wormhole. These theoretical tunnels through space-time could connect distant points in the universe, or even different points in time. While wormholes remain theoretical, their existence is consistent with Einstein's equations. If we could create or harness a wormhole, it could potentially act as a bridge, allowing us to travel vast distances or even journey through time. Section 5. Paradoxes and possibilities. Unraveling time travel's mysteries. The concept of time travel is riddled with paradoxes. One of the most famous is the grandfather paradox. What if you traveled back in time and prevented your grandparents from meeting? You wouldn't exist to travel back in time in the first place. Such paradoxes highlight the complexities of time travel. They question our understanding of cause and effect, free will, and the nature of reality itself. Despite the challenges and paradoxes, scientists continue to explore the possibilities of time travel. Some theories suggest that time travel might only be possible in one direction, or that alternate timelines might exist, preventing paradoxes. The quest to understand time travel is a journey into the unknown, pushing the boundaries of human knowledge.